Hey Algebra 1, we're still in Chapter 2, and we're looking at solving equations with variables on each side. We are lucky today with only one vocabulary word. That word is identity, and it refers to the equations that are true for any value used to replace the variable. So an identity basically is you're going to see the same thing on one side of the equal sign as you do on the other. So you might see 3x plus 4 after working on a problem on one side and then 3x plus 4. And then you would say, well, wait a minute, what can I do? Oh no, if I subtract both sides, it's just going to be 0 equals 0. Well, yeah, that's true. And identity means it doesn't matter what value I put in for x. If I put 2 in here and 2 in here, right, clearly it's going to be equal. An identity can come out as x minus 4 is equal to x minus 4. The key to noticing an identity is that you have the same thing on both sides. An identity also could be like 0 equals 0, 7 equals 7. Once it's the same thing on both sides of the equation, you know that the equation is true for any value of the variable. Let's get on to some examples. Okay, before we get on to some examples, let's talk about steps for solving equations. I do not mind if you don't copy this down. I even thought about playing some mellow music in the background just so you can have a chill moment, but I won't do that. I will definitely allow you not to copy this down, but I'm going to just tell you some steps, what you want to do when you solve equations. So the first step is to simplify each side of the equation. And this is really important. A lot of you have been playing around with the concept of simplify, but simplify means to join like terms, to add, subtract, multiply, divide, do whatever you can do in terms of those operations. And you want to do that on either side of the equation so each side is as simple as possible. The second step is to basically gather your variable terms on one side of the equal sign and then put the constant terms on the other. So you want to end up at this stage with something like 4x plus 3x equals 7. Notice that all of my variable terms are on one side, and 7 does not have a variable next to it. It's just a number by itself. That's called a constant, and that's what you'd want to see as you're solving an equation. In fact, we would not leave 4x plus 3x like that. We'd probably have 7x is equal to, I think I had a 3 over here, I don't remember. 7x is equal to 3, and then what you would do here, the final step, what would you do at this point? You guys can tell me the final step. What would you do here? Hopefully you answered divide or multiply to solve. So in that case, when you get to the point where all your terms on one side are x terms or whatever your variable term is and all your terms on the other side are constants, then you are either going to divide or multiply to solve. Let's do some examples now. With this equation, we have a variable on both sides, so that's what we're doing. We're solving an equation with variables on both sides. As I see it, each side of the equal sign is as simplified as possible. There's not much more that I can do. 2 and 5k are not the same types of terms, so I can't join them together. Similarly, 3k and minus 6 aren't the same kinds of terms. So what I like to do, sometimes I draw a line down the center. I like to decide where I want my variable terms. I'm going to put my k's over here. And the reason why is because there's more k's over here. I already got 5 k's on this side, so I'm going to leave my k's over here. You don't have to. You can do it another way. So my k terms will be here and my constants will be on this side. And so what I'm going to do is I'm going to move things to where I need them to be. Somebody doesn't belong on this side. I've got 2 plus 5k. That's a k side. So I'm going to get rid of the 2 by adding its opposite, by doing the additive inverse, adding the opposite. So then this becomes 5k is equal to, stay with me now, is equal to 3k minus 8. And so I'm feeling really good because it's looking a lot better. It's looking simple. I did the same thing on both sides, so I feel confident that I've done right. But now I need to, I want this side to only have constants. And so something has to go, and hopefully you recognize that it's the 3k. I move the 3k and I add the additive inverse to both sides, and what I find is that I get 2k is equal to, this is gone, negative 8. So I've done the first step, which was to simplify. There was nothing to simplify. Then the second step, said gather things to both sides, on, gather the k terms on one side and the constant terms on the other. And the third step, here's the third step. We're going to solve by division, because to get rid of this to get rid of this 2 that's bothering k, since it's bothering it by multiplication, I'm going to get rid of it by division. So k, I'm going to put my answer over here, k is equal to a -4. So here in example 2, we're looking at solving some of these types of problems with the variables on both sides, but also with grouping symbols. We've got this parentheses. So what we're going to do is what we know how to do. We're going to do the distributive property. So on this side, I'm going to simplify, because that's the first step. Simplify both sides as much as you can. So let's simplify this left side. 6 times 5 is 30m. 6 times a -30 is going to be a -180. And I think that's as simple as that left side can get. Let's move to the right. I'm going to multiply 1/3 times 24m and 1/3 times 12. 1/3 times 24 is really 3 divided into 24. So I get 8m. 1/3 times 12 is really 3 divided into 12, and I get 4. So I'm left with this. Both sides seem as simple as possible to me. I can't simplify this any further. So now I have to choose where I want different things to go. And let me utilize color here, because sometimes that's helpful. So this is going to be my m side. And this is going to be my c side. And you remember c doesn't mean the variable c in this case. It means the constant terms. So I want the constants there. And let me draw my line down the center. And let me return to my black marker. All right. So here's what we're going to do. I'm going to get rid of the 8m here, because I want my m terms on this side. So when I clear that up, I recognize that this side is left with just the constant of 4, and this side now has 22m minus 180. My next step, these are still equal. My next step is to add 180 to both sides, because I've got to move this constant over here. When I do that, I'm left with 22m is equal to 184. You guys know what this is. We've reached the third step. The third step says finish this problem by multiplying or dividing. In this case, we're going to divide, because 22 is attached by multiplication. So, swoop delicious, that's gone. M is equal to 92/11. And I'm really satisfied with an answer like that. That doesn't bother me. It's an improper, but it's at least reduced. It's an improper fraction that's reduced. 22 doesn't go in evenly. I would prefer that than a decimal, and also it's actually much easier to come by. So sometimes weird things can happen when doing problems, and we're going to talk about those weird things in these couple of examples, and this is find special solutions. So we're going to process like we usually do. We're going to simplify each side, so 5x plus 5 is as simple as that side gets. Let's look at the right. We're going to rock the distributive property here, and so I get 15x minus 12 minus 10x, and then 5x plus 5 equals 15 minus 10x is going to give me 5x. So I'm just joining like terms together. These guys are alike. Boom. And then minus 12. And then look at here. Look at this nonsense. If I were to do just like you guys were told to do, move things over to where let me fix this so I can follow the rule that I told you guys to do. Okay, so I drew a line down the center. We're going to choose one side for x's. Let's say the x's belong over here. Let's say the constants belong over here. If I'm going to do that, watch what happens. I subtract 5x from both sides. And already you guys see the problem. This is 0, this is 0. I end up with something crazy like 5 is equal to negative 12. And yes, you should scream shenanigans right now. That's a problem. And what we see here, when you get something that is a lie or that is totally untrue or that cannot be, you know that there is no solution for that problem. There's no solution. There's absolutely no way that I can figure out an x that's going to make, at the end of the day, 5 equal negative 12. So when you get a lie, there's no solution. When you get something that's untrue, there's no solution. So that's one thing that happens that's funny or weird or special when we have these problems. Let's take a look at this next one. I'm going to rock the distributive property. When I do that, I get 6b minus 3 minus 7 is equal to 6b minus 10. And 6b minus 10 is equal to 6b minus 10. You see what's happening. It's like looking in the mirror, right? And you remember what we call this from our vocabulary word? This is an identity. So all things work here, all real, all real numbers work. I know you guys call that hashtag, but back in the day, that was pound sign and number. So all real numbers are going to work in this particular problem because it's the same thing on both sides. I was going to skip this example because it was hard to write it down myself and give enough space to do some work, but I just took a picture of it and we'll talk about it. So this is example 4, standardized test example. So here is a beautiful problem. It really is kind of nice. It says find the value of x so that the figures have the same area. So I want the area of this rectangle to equal the area of this rectangle. We know that and let's call this rectangle A and rectangle B. So I want their areas to equal. Well, the area of rectangle A, it would be 10 times x, because we know that's base times height. And the area of rectangle B is not as easy to write, but we can do it nonetheless. We recognize that it's going to be 6 times something times the sum of these two values. So that's going to be 6 times 3 plus x. So if I want, you guys should tell me when I put silly things here. That's not a mistake, by the way. I fixed it myself. All right. So area B, the area of rectangle A is 10x. The area of rectangle B is 6 times 3 plus x. So what we're going to do is we're going to set these guys equal to each other and solve the equation. Okay, so you see over on this side, I tried to write the equation nice and tiny. So let's take a look at it. So 10x is equal to 6 times the quantity of 3 plus x. That means that 10x, nothing to simplify over here, but I can simplify this side, or at least, get rid of, use the distributive property and so forth and so on, is going to give me 18 plus 6x. You guys can solve this in no time, right? We're going to subtract 6x on both sides. And that's going to go away. I get 4x is equal to 18. And therefore, x, I'm going to divide both sides by 4, x is obviously, just so obviously, equal to 18 over 4, which can be reduced to 9 over 2. And when we take standardized tests, we need to make sure that we write our answer in terms of the way they have it. The answer choices, that is. Obviously, that's not 3. 4.5 is the answer. I can definitely check the other ones, make sure they haven't written it in some kind of other term, but the answer is 4.5. So the answer to that is B. All right, guys, this video was a little bit longer than I wanted it to be. However, we've come to the end, and your assignment is as follows. Please have an excellent day, and I look forward to seeing you guys next time.